Are you ready, kids?
Aye, aye, Captain!
I can't hear you!
Aye, aye, Captain!
Oh! Who lives in a pineapple under the sea?
SpongeBob SquarePants!
This is SpongeBob. He has a flat cerebral cortex. Mine has more wrinkles and is more defined. It means I can do high-level thinking. I also form more neural networks.
So, as we can see, Mr. SpongeBob SquarePants, a great worker at the Krusty Krab, has had a lot of seizures that have been affecting his personal and mental life. To end these seizures, we will be performing a surgery by splitting his corpus callosum. Let me see this, please. So this is his brain. His corpus callosum, by severing it, we have split the two areas of the brain, thus allowing the seizure from this end not able to end from this end. So now the seizures have stopped, thus helping the patient and stopping the seizures.
Thus performing a split brain surgery.
2,000 years later.
As you can see, SpongeBob is perfectly functioning in normal society. This is because since he is a child, his brain is much more plastic and has plasticity, meaning that his brain can adapt when certain parts of it have been removed. Reflex.
I am a neuron.
I'm a glial cell. Good thing I formed neural networks and learned how to throw a football.
I cannot see. My occipital lobe is damaged. Oh, it's brighter. It's clear.
Kenny! Kenny! His temporal lobe must be damaged.
How you doing today, Kenneth? Not bad, buddy. How's wife and kids? Good.
Hey, give me money!
At this moment, Kenny and Raza's fight or flight response has kicked into action.
Ah! If you look here, you see a wild Kenneth. And Kenny's eating habits fuels his pituitary gland for his body to grow. The action potential is a brief neural impulse traveling down an axon, much like Kenny chugging his drink. Now that Kenny's done chugging, he's going through a refractory period, or resulting resting pause, after the action potential. This is an example of someone with Broca's aphasia.
Hi, how are you?
This area of the brain was discovered by Paul Broca.
This is a patient with Wernicke's aphasia. How are you?
I'm pretty, you're fine, your shirt's cool.
This is the cell body. This right here is the threshold. Once I press this in, it creates an all-or-none response, turning the light on.
I am an axon terminal. This is the myelin sheath. The myelin sheath keeps me warm and protected. These are the axon terminals. The tight junction in between them are the synapses of the axon terminals. Anything from a neurotransmitter can enter these synapses. Thus, SpongeBob, he's a neurotransmitter. Ta-ding. Yes, sir. Oh, look at that. Our president's being an idiot again. Hey, Parker, how you doing today?
Not too good. Kind of totaled the car.
Your insurance might not cover it. What happened?
My frontal lobe made a bad decision. I rear-ended somebody.
You have hurt my amygdala for the last time. First it's fear, now aggression. Now get here.
Parker, what's up, dude?
Charles!
Their somatic nervous system has consciously helped them high-five each other by helping move their skeletal muscles.
Endorphins act like neurotransmitters that soothe the body and act like painkillers, much like this back scratcher is soothing Parker West.
Raza, as an antagonist,
is inhibiting Charles D hormone from entering his destination. Raza, as an agonist, is helping Charles D hormone to his destination.
I'm Dr. Charles Brown, and I'm about to sever this man Parker's reticular formation, thus sending him into a coma. Snip! The sympathetic nervous system stimulates the body to respond to threats, much like Parker is when Raza attacks him. Parker's parasympathetic nervous system is working to calm him down after the fight has just occurred. Genes contain the chemical makeup and physical makeup of all humans, much like Raza's genes make him brown, and Parker's genes make him white.
Charles's sensory neurons are going up to his somatosensory cortex to tell him that this stove is very, very hot.
Ah!
Can you not?
No, okay, time out.
Raza!
How are we gonna act out neurons?
We're not gonna do that right now. What's it do? What?
Alright, bro, we can do it.
Raza!
I am a neuron.
No, hold on. Nerve, you are a nerve. Not
He's a neuron!
Neuron! Raza!
This is SpongeBob. I am Kenny Chen. I have a cerebral cortex, which makes me to have a more developed thinking. This is SpongeBob. I am Kenny Chen. I have a... I cannot see. Are you ready?
Yes!
Why you do today, Kenneth? Not buddy. Not bad, buddy.
Hey, give me your money!
At this moment, Kenny's fight is...
If you look here, you see a wild Kenneth eating his food. His pituitary gland is allowing him to obtain the nutrients.
I'll do that right now.
If you look here, you see a wild Kenneth eating his food.
This is an example of Wernicke's aphasia.
That's wrong.
Parker, Charles, what's up? Their somatic nervous system has allowed them, by moving their skeletal muscles,
You messed up.
own.
Parker, what's up? Charles!
Go. Raza is acting as an antagonist, which inhibit Charles D hormone from entering the endocrine system. Raza is acting as an agonist, helping
So bad!
Charles D hormone entering the endocrine.
You can stop talking.
Can you guys not like? You guys messed up right here. You guys messed up right.
He hurt me.
Raza is acting as an agonist. He is helping Charles D hormone on his way to the endocrine system.
No, it's not too. As the boys fight, their sympathetic nervous systems will kick in, allowing them to. As the two boys fight, their sympathetic nervous systems will cause them to be stimulated by the responses.